This week's camp is called Scientists, Wizards, and Olympians. It's an opportunity to solve some challenges that are presented by our group of heroes.
They can get creative, they can build things, they can try out new things. Oftentimes they're working with a partner, so they get to bounce ideas off of another person. And it's all under the idea that they are helping out Alexon and his team of wizards and Olympians that are heading out to defeat Ares, who has stolen the Sun Shield. The spell for the challenge was Ascend 'em, Stack 'em. So they were trying to stack hex nuts on their wands. Some of them were able to get a little bit more depending on the size of magnet.
Make sure you say the spell or it stops working.
Ascend 'em, stack. Ascend 'em, stack. Yes, I did it.
Oh,
Ascend 'em, stack.
They use a powder called Germ Powder because it reacts to ultraviolet light. The reason that they do that experiment is to see how you can pick up germs that you can't even see with your regular eyes. And it shows them that it's really important to always be washing your hands.
That is black like dust.
We asked them to help our heroes heat their food. So that was creating a solar oven.
We're putting a cardboard box with tinfoil on it, and then black paper with clear foil, and tape it all together. And we're gonna put some pools here for balance. Black paper at the bottom because it absorbs more heat.
What kind of food are you going to make in the oven?
We're gonna make marshmallows.
what if we do one like this?
Hopefully.
And then we looked to see which one had gotten the highest temperature and melted butter onto bread, melted cheese, and melted marshmallows. So they had the sun shining off of the aluminum foil into the oven, and then the heat was trapped between the black paper and the protector.
It's 105 degrees.
The one that worked the best totally taped their plastic protector around so that no hot air could escape. Our heroes wanted to take a frozen potion with them on their quest, and we needed a way to keep it cold. So the challenge was to design a container that would keep the ice cube from melting.
And then fold it in half again. We'll make sure the edges line up. There you go. And wrap it around. And yeah, there you go. That's what you can do.
So I'm planning on making it so warm that it's cold. This is where the potion is gonna go. We put a cup inside, cotton balls around it, and tinfoil around it.
They got a beaker with ice, put it in right when we were ready to test it, let it sit, and then we went back and checked it a couple times. Smuggling liquids was where we asked them to hide certain liquids in something to see if we could make them disappear. We gave them hydrogel crystals, and they had a variety of liquids to try to see which liquid would absorb the best and which would absorb the quickest.
Water and club soda is like the best.
Ares and his group of bad guys had developed a freezing spell that they were going to try to use on our heroes. So our heroes had an odd assortment of items that they were taking with them, and we wanted to see would any of them withstand the freezing spell. We had put the items in liquid nitrogen. Liquid nitrogen has a freezing point of 346 degrees Fahrenheit, but when it starts to react, it's at the 320 degree temperature. So when we took it outside, it starts to bubble. It's still very, very, very cold, but the warmer air is causing a reaction, and that's when you get the floaty gas that comes out and creeps along the ground.
You see how bouncy that is, right?
Do it, do it, do it, do it!
That didn't bounce.
It's just like ice.
Some of them, like flowers, turn very brittle, and you can just smack it on the concrete and it disappears into little bits. Oxygen shrunk and condensed inside the balloon, and they got this really odd shape. And when you pulled it out into the air and watched them, they just slowly uncrinkled and unfolded and turned back into the regular balloon. So now that they had a little bit of an understanding on liquid nitrogen, we were going to use a spell to make someone disappear. Our lab coordinators had set up 6 very large buckets. They took very hot buckets of water and all at the same time.
4, 3, 2, 1.
We did 2 activities that involved Bernoulli's Principle. So Bernoulli's Principle is the idea that as faster air is moving above, it's reducing the air pressure on top, and slower air below is allowing things to kind of rise up. One was wind bags. It's a long plastic bag, and they're trying to fill it up with one breath. In the toilet paper challenge, they had 3 people that were the toilet paper holders, and they had to try and cover one person from their group in toilet paper. You're reducing the air pressure on top. The air is moving faster and it's slower underneath, and it's allowing it to unravel. Their wand challenge was to do a spell called Pat It Potom, and so they're trying to make the soda bottle clear.
Pat it, Potom. Pat it, Potom.
Now look, does it look any different yet?
Yes.
By adding the milk, the phosphoric acid molecules attach to the milk proteins, and then it weighs them down, and as it falls to the bottom, it's pulling the color out of the soda.
For electricity to flow, it needs to be a closed circuit, an open circuit, a long circuit.
There were various members of the hero team that had an affinity for electricity, and the point was to help them understand how you make a circuit, as well as what is conductive and what is not. So we asked them to experiment with a flashlight and what does it look like and what are the parts.
We're making like, no, you have to.
Using teeny tiny LED lights, some batteries, wires, some tubes.
The battery connects to wires, which connects to the light bulb, and the light bulb is going to connect up here, and that's going to make it shine brighter.
I grabbed this with one hand like that, and then I connected that, and it turned on.
We have an insulated dough and a conducting dough. They had to form it into a circuit to get LED lights to work.
Made over there, when there were lights all the way down, that was a parallel circuit. When we made the circuit in the one big circle, that's called a series circuit.
When you're working with circuits, you have to think about the flow of electricity. If you want to break the circuit, you can use this dough. And if you want to keep the circuit, you need to have this dough, and you need to have your lights going this way, and here's where you need to put your battery.
The conductor produces light, and the insulator keeps the light in. The white is the conductor, and then the green is insulated.
Catapults! And mine's portable.
I'm doing stats.
So the catapults that they're working on acts as a lever. They have the option to design 2 different catapults and to choose which one they think would work out the best and give them the greatest distance. The Olympic challenge is to walk on water. So one of the things that they're going to face as they travel to England on their quest is that they need to travel through Morecambe Bay, which has quicksand in it. The task for them is to see if they can walk across oobleck, because it's both a liquid and a solid, and so its reaction is different depending on the amount of force that you put on it.
Punch it like this.
On that field.
One of the things we're going to do is see if they can catapult marshmallows over the oobleck so they can get back to safety.
All right, you can cross the bridge. Good job.
Kids enjoy so much an opportunity to play and experiment and try.
It's the fun things in science that get people more and more interested in science and wanting to do science longer and longer in life.
Get this rubber off of me. I'm a snowman.
And one of the things that I've really tried to emphasize with the kiddos in my room is it's okay to fail.
Any food? Chicken and dumplings. No, I would make Chinese food. Pizza.
Ew, it's a pizza box.
Then later they can kind of build up that patience and put their time and efforts into science experiments that might take a little bit longer that could yield results, could change the world someday.